To answer question number 1, to find the limit as x approaches 5 of x squared plus 1, the best thing to do is probably look at the graph. So here's the graph of the function. Scroll down a little bit so we can see it all. And so what I want to know is, as x gets closer and closer from both sides to 5, so as we come in, what's the height of the function? Well, let's just draw in, and graphs can be deceiving, but this will give us an idea of what we think it is. So if I go up to the line, okay, I get, I don't know, roughly a height of 26. Okay, now maybe I'm a little bit high, maybe I'm a little bit low. It really depends on how accurate I am. Let me see if I can come across just a little bit more accurate this time. But it looks like 26 is the limit value. So it looks like the limit as x approaches 5 of x squared plus 1 is 26. Now let's go through and identify some of our variables here. We have an L value of 26. We have a function that's equal to x squared plus 1. We have an epsilon value equal to 0.08. We have a c value of 5. And we have a delta value that we'd like to find out. So we don't know what delta is. So let's go ahead and continue with this picture. Let's grab purple here. Now, I want the error amount, the amount of distance between the limit and the function to be minimal. I want it to be 0.08. So what I'm going to do is draw in my lines, and I'm going to go 0.08 up, so 26.08, and 0.08 down, so 25.92. This number right here is the limit plus epsilon. This number right here is the limit minus epsilon. So we'll drop down. The question is, how far in each direction can I go? Because that's my delta value. That's what we need to find. So our value is 5. So what we want to make sure is that the function evaluated at 5 plus a little bit. So we can go ahead and call this, since we're going a little bit, that little bit we'll call delta. So 5 plus the delta, we need to make sure, so this is delta, this is negative delta. So from 5, if we go to the right, we know that 5 plus delta, the function evaluated at that, has to be less than 0.08. So if we solve this, guys, the function of 5 plus delta is 5 plus delta squared plus 1, and that's going to be less than not 0.08. It's got to be less than 26.08. So let me explain why I'm saying that. What I'm saying is, this guy right here, that value on the x-axis is 5 plus delta. It's a starting value of 5. This just became a mess down here. Let's redraw this. So here's our 5 value that we came up from. The distance from here to here, that is 5 plus the little bit that we're going to go over. So if I take the function, this height right here is the function defined at 5 plus delta, but we need to make sure that that is less than 26.08. So to do that, we'll figure out what delta is over here. So this is going to be 25 plus 10 delta plus delta squared plus 1 has to be less than 26.08, which means that 10 delta plus delta squared has to be less than 0.08. If I solve this using the quadratic formula, I get two answers. I get a negative answer for delta, but that doesn't make any sense because delta is a distance, and so we set up here delta has to be positive. So our value for delta when we use the quadratic will be 0.00799. We'll say 361. That's close enough. So here's what I'm saying. If you take and you go out this way to 5.00799.361, if you take any number in between 5 and that number, you'll get a height value that's less than 26.08. Likewise, if you take that delta in the other direction, okay, you get a value that's 5 minus that delta value, and any value, any function value, x value, that's described in that area will get you to a height that's more than 25.92. So our delta value should be approximately this number.